Okay, the next concept on your SLO is absolute value equations. So this will start with number 9 on the SLO. And your first one will be something along these lines, where the absolute value sign is already all by itself. Because step number 1, we'll go to number 10 here, is to get rid of anything on the outside of the absolute value. So if I have, like here, a 4 on the outside, I would have to get rid of that. And then also if I put a constant over here, like this -9, I'd also have to get rid of that before I even start the problem. So if I go over to number 10 and just show you the difference, it's like the two-step equations that we did before, right? I would get rid, this is a constant since it's just a number being subtracted on the outside, so I'm going to add it and make it 0. So if I add 0 to something, I'm just left with that same thing, all right? And then this is, the 4 is like a coefficient, so I want to make it a 1, so I'm going to divide. So now 1 times something is still that something. So then after all that, now 9 and 10 will look the same. So that's the only difference between the two. Now, how do I, once I got the absolute value by itself, what do? Well, since absolute value means everything is positive, okay, that means that this expression z minus 10 could be a positive 21, or this expression z minus 10 can be a negative 21. Let me take a second and explain that. What I'm saying here is that the expression z minus 10 could be a negative 21 because this is a true statement. The absolute value of negative 21 is still 21. And then over here, the absolute value of 21 is still 21. So you really have two possibilities. The question is, what value of z would make this positive 21? And what value of z is going to make this negative 21? Well, that's what these equations will tell me. So what value of z, if I were to subtract 10 from it, would be 21? Okay, well that would just be, you would just have to add 10 and say 31. Okay, and if I bring this together, I say, okay, well, if I put 31 back into the expression to check my work, I would have 31 minus 10. Is that the same thing? Yeah. All right, that's right, 21. All right, we know is 21. So you can check these just as well as you checked the equations in the beginning on the previous 3 problems. So you can always, any type of equation, you can just plug it back in. So the question is, okay, well, what about that one? Why is this an answer? Well, if I take it and I plug it back in, I have inside the absolute value, I have negative 11 minus 10, which then is negative 21, which then again, if I take the absolute value of something negative, okay, since the absolute value just means the distance from 0, so negative 21, this is 0, negative 21 and positive 21 are the same distance. So in the absolute value realm, they are equivalent. So if it's absolute value of a positive, it stays positive. Absolute value of a negative turns positive. All right, so you'd finish this up the same way. You say, all right, and you will get fractions on your SLO. So just get used to that fact. Their answers will not always come out nicely. So these are, you just get two-step equation here. So 1/2 minus 2 is negative 1 1/2. And then when I divide that by 7, okay, that's going to be a decimal. And for your SLO, you can leave it as a fraction or give it to me as a decimal. I'm not going to be picky on what you decide to leave your answer as, because what I'm testing you on is, are you able to isolate the absolute value and split it up correctly? So if I get the decimal value of these, you would have roughly negative 0.21 if we were rounding. Now you can also use second f to d, which change it to a fraction to a decimal. Again, this I always love fractions better because they're not rounding. So this answer is rounded. I would accept it, but if you use second f to d on your calculator, it's more accurate. And if I do this one, negative 2.5 divided by 7, okay, you're going to get roughly negative 0.36, okay? But if I do second f to d again, I'm going to get the exact answer, which is negative 5 over 14. Both answers are acceptable. Just want to make sure that you're able to isolate the absolute value and split it up. Now the very last absolute value will be number 11, and here you're going to have the absolute value isolated. And there's, in other words, on the right side here, you have nothing on the outside of the 4y plus 12 like you did with number 10. Okay, we had the negative 9 on the outside, and we had the 4 on the outside of the absolute value, so I had to get rid of those. Well, here, you don't have that, so we don't have to worry about that. But what we do have to worry about is how do I split this up if my left side is an expression? Because if you look at this one here, all right, the other side here was just a number. So I just set it equal to the positive 21, and I set it equal to the negative 21. So what do I do if it's an expression? Well, you still set it equal to the positive and to the negative. Okay, so you can put the key here is whatever's on the inside of the absolute value does not change. So if you look up here, the z minus 10s, as I split it up, just stayed as z minus 10. The only thing that changed was on what was on the other side of the absolute value equation. So I had a positive 21, and then I had a negative 21. So whatever's on the other side is what changes. So what's on the other side here? Okay, I'll try to color code it. All right, so this is what's going to change. So for one of these, okay, you're going to need the negative of it. Okay, so I'm going to have to put a negative sign, and what essentially happens is it just a negative of something will change the signs of both. And on this side, okay, it would just remain the same. So there's your setting one of them equal to the positive and setting one of them equal to the negative. But a negative of an expression, this one here, changes the signs. So what was negative 6y now is positive, and what was positive 4 is now negative. And now, once you simplify that, now it's just back to like number 8 on your SLO, where you have a variable on both sides. So I can add 6y or subtract 4y. I'm choosing to add. But the whole situation here is that you have variables on both sides. As far as either side of the equation, it's already simplified. So we now have to combine like terms and get that variable on the same side to make it a two-step equation. So now I have that. Now I can just get rid of the constant for both and then divide. So I subtract. Okay, and again, get comfortable with having fractions or decimals. Okay, I can do that one in my head. Negative 4/5, and then here, if I add 4, you're going to have, you divide by 2. Okay, and that is how we solve an absolute value equation if the other side is an expression rather than just a number, okay, like it was with number 9.